Earth is unique in the universe. It provides stable and moderate temperature for the various circulations and cycles in the natures, which forms of countless lives. Because of the carbon dioxide and other greenhouse gases in the atmosphere. It's like the glass covered on the greenhouse, which maintains the temperature and causes greenhouse effect. However, industrial activities consume extensive fossil fuels, such as oil, coal and natural gas, resulting in producing excessive carbon dioxide. With the excessive greenhouse gases, the greenhouse effect is getting too strong, which causes global warming. It requires moderate amounts of carbon dioxide on Earth. But when the carbon dioxide concentration of atmosphere is out of balance, it will threaten the natural circulation of the Earth. Promoting of a comprehensive energy-saving measure to reduce carbon dioxide is the top priority. There is a high-profile way to reduce carbon, which is carbon capture, storage and utilizing, referred to as CCSU. There are lots of research teams devoting themselves to research and development on CCSU technology in Taiwan. The topic of post-combustion carbon capture is researched by the Professor Zhang's team. They build up a pilot plant in Malayao area of Formosa Petrochemical Corporation. First, the chemical absorption method absorbs carbon dioxide through a liquid absorbent. Then, using a high-G rotating packed bed, RPB, can reduce 2/3 volume of the traditional carbon dioxide absorption tower, but also enhance the gas treating capacity. The chemical absorption method is using alkaline waste as adsorbent to adsorb carbon dioxide. The team is to improve the efficiency of gas adsorption process with supergravity carbonation process. And the formatted carbonated converter slag can be made of green cement. The chemical looping process technology is the use of repeated oxidation reduction reactions between air reactors and fuel reactors, accessing to high purity carbon dioxide. The topic of pre-combustion carbon capture is researched by the Professor Xiao's team. Gasification is a process that converts coal or biomass materials into carbon monoxide and hydrogen-based syngas, and then utilizing a unit of gas purification to separate carbon dioxide. It can increase power generation efficiency to 60%. Besides, the production of syngas can be applied in multiple purposes, and high concentration of carbon dioxide can be obtained. At present, China Steel Corporation is invited to cooperate for proceeding and assessment of factory construction. The solid absorbent pressure swing process has been applied to Taiwan Power Company. In the future, the first 15 megawatt of domestic commercial gasification equipment will be established in Taiwan. This can help the domestic industrialization technology and can be internationalized. Professor Wu's team is studying multi-fuel oxy-firing technologies for emissions reduction. Combustion air is completely replaced with oxygen in oxy-fuel combustion for carbon capture. Integration of oxy-firing of biomass and wastes through flue gas recirculation and carbon fixation technology based on furnace slags is currently investigated to reduce carbon emission directly. In addition, emission reduction can also be achieved through oxygen enrichment of combustion air. Geological survey for carbon dioxide potential storage sites in central Taiwan are led by Professor Lin's team. Considering West Plain of Taiwan is densely populated area, most potential storage sites are proposed in depleted gas fields or coastal open saline aquifers. The storage type of coastal open saline aquifers is suitable for Taiwan, especially most of power plants are settled near coast. and injected carbon dioxide in western Taiwan will migrate toward Taiwan Strait according to buoyancy that could decrease carbon dioxide leaking risk. Carbon dioxide injected to geological structure is a mature technology for petroleum. Chinese Petroleum Corporation also has similar experience to storage natural gas underground that safely passed through several big earthquakes. Carbon dioxide will be injected at more than 800 meters depth, and concurrently, injection pressure will be monitored and adjusted instantly to prevent microshakes. Right now, there have been no reports of large earthquakes in the world that have been induced due to carbon dioxide injection. In the case of carbon dioxide utilization, the microalgae-based carbon reduction technology has been studied by Professor Zhan's team with the largest microalgal carbon dioxide fixation cultivation plant in Taiwan. By using flue gas carbon dioxide and wastewater for the production of microalgae, high-value algal biomass can be obtained, accessing to media attention. The microalgae-based carbon reduction technology has matured commercial applications. Chinese Steel Corporation has employed this technology for 3 years, giving 60% flue gas carbon dioxide removal efficiency. The microalgae biomass produced can be used to produce biodiesel, lutein, and fish and shrimp feed. The technology has also been transferred to a biotechnology company. The team has also started up a new venture company for commercializing their microalgae-based carbon dioxide or waste utilization technology, aiming to achieve the goal of converting waste resources into gold. In addition, the Professor Yu's team and China Steel Corporation were in cooperation with carbon reduction research. At first, a novel carbonation system of basic oxygen furnace slags, or BOF slags, was constructed in the steelmaking plant. The BOF slags were used to absorb carbon dioxide in flue gas of copper stoves for hot blast to form carbonated BOF slags. And then using carbonated converter stones to cultivate seaweed, the biocarbonization study was carried out. Results showed that the carbonated BOF slags could promote the growth of algae and enhance the carbon fixation rate. The recent study was the use of carbonated BOF slags to concrete artificial reefs and proceeded on-site field experiments about marine ranch. After 3 months, the artificial reef surface had been bred up seaweed, bryozoans, sponges and corals, and fishes were gathering around the reefs. It was confirmed that these artificial reefs had the positive benefits of reducing carbon and increasing marine resources. At present stage, there are considerable research and potential development for CCSU in Taiwan. During the commercialization process, these technologies apply intensively with large carbon emission factories, such as establishing demonstration plants with China Steel Corporation, Formosa Petrochemical Corporation, and other companies. The relevant key technologies have transferred and formed a joint development agreement. In the future, it will continue to develop CCSU technology and its industrialization in order to achieve carbon dioxide reduction.